Hi everyone, Dr. Abhishek Dhar from Talanta here. In this video, we are going to discuss a very common reaction mechanism from RNH2 to ROH. That means from 1 degree amine, we are going to get alcohol. And the required reagent is NaNO2 plus dilute HCl. So if RNH2 reacts with NaNO2 plus dilute HCl, or it is also written in this manner as well, nitrous acid HNO2, to generate ROH. So this is a very common reaction. Those students who are in class 12 or in their honors courses, their undergrad courses, every time they have to use this reaction. Specifically, it's very important for class 12 any competitive exam like JEE or NEET. So we will discuss the mechanism from very basic fundamental. When at first NaNO2 reacts with dilute HCl, a double displacement reaction occurs. It produces HNO2, nitrous acid, along with sodium chloride. So nitrous acid, its structure is this one, and this is quite unstable at normal room temperature even. So what happens, as it is very unstable, it actually cleaves very readily to generate OH minus nucleophile and NO plus electrophile. Why it cleaves in this way? Why the bond electron pair do not go to this way? Because oxygen is more electronegative than nitrogen. So the electron pairs are more strongly pulled up by the oxygen atom, not the nitrogen. So oxygen is getting negative charge, and nitrogen, as the electron is removed from the outermost shell of nitrogen, it lacks one electron, so a plus charge is being developed on the nitrogen atom. So now these electrophile will take part in the reaction with RNH2. This is RNH2 and this is the electrophile. So at first, the lone pair of nitrogen atoms attacks to the N plus, and this intermediate is generated. So here one thing, it's quite logical. In this nitrogen atom, in this structure, this nitrogen atom, it is getting positive charge. So when nitrogen is getting positive charge, it becomes unstable. So because nitrogen is substantially electronegative in nature, so it will try to release one extra proton to generate its neutral state once more and to get back its lone pair. So on that note, what will happen after math, one proton will be released from this tetra coordinated nitrogen, and as a result this will be generated. Now this is NO, nitroso group, and this is with respect to this functional group. This is the alpha atom, and in this alpha atom one hydrogen is attached, so a probability of tautomerism is there. So in general, when we talk about tautomerism, the first thing what comes in our mind, ketoenol tautomerism. But except ketoenol tautomerism, more two types of tautomerisms are there, and this one type of tautomerism is oxymino-nitroso tautomerism. So here that tautomerism will happen, oxymino-nitroso tautomerism. So actually this hydrogen, this sigma bond will be shifted over here, and pi bond will be shifted over the O atom. Now these O atom will get minus charge and single bond, and when this bond is shifted over here, this hydrogen is releasing its valence electron, and that's why this hydrogen in this step is released as H plus. That H plus will be accepted by this generated O minus to form OH. So what will be the final tautomeric form? That is R N double bond N and OH. Well, now it is happening in acidic medium, because the initially we have added dilute HCl. So now as it is acidic medium, so now this lone pair over oxygen atom will accept this H plus to generate OH2 plus, and now OH2 plus is a very good leaving group. In the next step, what will happen? These lone pair over this nitrogen atom, due to strong pull of the electron pair from these O plus, the final pull will be over the lone pair of these nitrogen atom, and as a result the lone pair will be shifted over here, and this sigma bond will be cleaved to generate water molecule. As the nitrogen of the middle is getting tetra coordinated and the lone pair is being released over here, so of course logically a plus charge has been developed over these nitrogen atom. So N2 plus is a very good leaving group. In the next step, what will happen, this bond will be shifted over here due to drastic withdrawing effect, minus I effect of these N2 plus moiety. As a result, one electron will be lacked in these R, and as a result, as the electron is being released from the carbon atom of the R in the final call, so here R will get a positive charge. That means carbocation will be generated. So R plus will be generated and N2 will be released as gas, and so we can say that this particular step is entropically favorable as well, because here nitrogen, a gaseous substance, is being generated. As a whole, the randomness, that means the entropy of the system increases and the step becomes entropically favorable, and water is present in the medium. In the final step, what will happen, the water will attack as nucleophile to R plus to generate ROH2 plus. We all know that, all in the sense who consider chemistry in a serious way, from the pressure of the course, or from the love of the course, or for something else. So they all know that when a very electronegative atom like oxygen is getting positive charge, this system becomes highly unstable. So it right now wants to get stable. So that's why one proton will be released. Sorry, uh, oxygen is more electron withdrawing, so the direction of the arrow will be in the reverse way what I have drawn earlier. So this will be a shift, and as this sigma bonded electron is being transferred over this O plus, that's why O plus is being neutralized to generate ROH. That's all for today's lecture. Thank you for watching. Thanks for liking and sharing this video with your friends. And if you are new to our channel, don't forget to subscribe our channel. Keep learning, be happy.